Hello and welcome to this demonstration of YellowDog's integration for Ray. Today we'll cover how YellowDog accelerates the Ray distributed computing framework with its open source integration. I'm Alan Parry, YellowDog CTO, and it's a pleasure to be sharing what we've created with you today. We're going to explore how YellowDog's integration for Ray combines Ray's simplicity and ease of use with YellowDog's unrivaled ability to scale compute infrastructure across massive clusters. Whether you're working on AI development, machine learning workloads, or complex computational tasks, this integration provides seamless access to virtually unlimited cloud resources. In this demo, we'll walk through the YellowDog platform, introduce the Ray framework, explain the YellowDog integration for Ray, and then finally demonstrate a practical Monte Carlo simulation running at scale. Let's dive in with an overview of the YellowDog platform. YellowDog is a cloud-native workload manager that accelerates large-scale, compute-intensive workloads across hybrid and multi-cloud environments. In terms of core capabilities, at its heart, YellowDog manages the full workload lifecycle by combining a powerful cloud-native scheduler with a dynamic orchestration engine specifically tuned for provisioning cloud resources at massive scale. The platform can easily manage millions of compute cores across multiple cloud providers and regions. Let's look at the key features. Firstly, we enable multi-cloud orchestration. YellowDog offers connectors for all major clouds, including AWS, Azure, Google Cloud, and Oracle Cloud infrastructure. You can deploy workloads across on-premises infrastructure, multiple cloud providers, simultaneously through a single unified interface. This is optimized through intelligent provisioning. The platform includes the YellowDog Index, which provides insight into cost, performance, processor architectures, geographic locations, and even data center renewable energy scores. Using this information, YellowDog automatically selects the best source of compute based on your business objectives, your constraints, and preferences. We take this further with a range of features to enable fault tolerance and resilience. YellowDog excels at using spot and preemptible instances, which can save 60 to 90% on compute costs. The platform automatically maintains your instance count if failures occur, ensuring minimal interruption to your workloads. Finally, our scalability. YellowDog has been proven in production to provision over 3 million concurrent vCPUs and build multi-region supercomputers in minutes. This level of scale is critical for time-sensitive computational problems in financial modeling, drug discovery, and AI training. YellowDog is accessible via an intuitive user portal, as well as through comprehensive REST APIs, SDKs for Python and Java, and a CLI. If you aren't familiar with Ray, here's a quick overview. Ray is an open-source unified framework for scaling AI and Python applications. It was designed to make distributed computing as simple as possible for Python developers. Ray's key innovation is that it takes existing Python concepts, functions, and classes, and seamlessly translates them to distributed settings as tasks and actors. This means you can parallelize your existing Python code with minimal modifications, often just by adding a simple decorator. Let's look at Ray's core components. Firstly, there is Ray Core, providing the fundamental distributed computing primitives, including tasks, actors, and objects. Tasks are the stateless functions executed across the cluster, whilst actors are stateful worker processes. Finally, objects are immutable values accessible across the cluster. Then there are the Ray AI libraries, including specialized libraries for common ML workloads, such as Ray Data, Ray Train, Ray Tune, Ray Serve, and Ray RL-lib for reinforcement learning. So why Ray? Ray minimizes the complexity of starting with distributed computing. You don't need to be a distributed systems expert to use it. It handles orchestration, scheduling, fault tolerance, and auto-scaling automatically. Ray also runs on any infrastructure, from your laptop to cloud-based clusters, and features a growing ecosystem of integrations with popular frameworks like PyTorch, TensorFlow, and scikit-learn. The framework has been adopted by leading AI teams worldwide and powers applications ranging from training large language models to real-time recommendation systems. YellowDog's integration for Ray is a cluster builder. It models a Ray cluster as YellowDog work and provisions YellowDog worker pools to provide Ray nodes. The integration handles the entire lifecycle, from provisioning the head node and worker nodes to tearing down resources when you're finished. There are 4 key benefits, including 1. Massive scale. YellowDog's integration for Ray enables you to rapidly spin up Ray clusters with thousands of nodes across multiple regions and cloud providers. Clusters that would take hours to manually configure can be provisioned in minutes. 2. Cost optimization. By leveraging YellowDog's intelligent provisioning and extensive use of spot instances, this integration ensures you get maximum performance within your budget. Resources scale up and down dynamically based on your workload demands. 3. Flexibility. Worker pools containing configurable numbers of Ray worker nodes can be added and removed dynamically during the cluster's lifetime. You can mix different node types, instance sizes, and even different cloud providers. 4. Hybrid cloud support. Run Ray across on-premises infrastructure and multiple cloud providers simultaneously, enabling you to leverage existing hardware investments while bursting to the cloud when needed. I'm sure you're keen to know more about how it works. Our open source Python library introduces a RAIDO cluster class to establish YellowDog credentials, set cluster properties, and provision the Ray head node. You can then add worker pools with specified instance types, counts, and configurations. The integration automatically sets up SSH tunnels for accessing the Ray dashboard and client, and optionally supports observability through Prometheus and Grafana. Monte Carlo simulations are computational algorithms that use random sampling to estimate probabilities and model uncertainty in complex real-world systems. A Monte Carlo simulation runs thousands or millions of scenarios with different random inputs to understand the range of possible outcomes. This technique is widely used in finance for risk assessment, in engineering for reliability analysis, and in science for modeling physical systems. Monte Carlo simulations are embarrassingly parallel. Each simulation run is independent. This makes them perfect for distributed computing with Ray. We'll demonstrate with a classic Monte Carlo problem, pricing the risk of an imaginary commodity. The method works by using geometric Brownian motion to estimate the price of a European call option. Using Ray, we define a remote function that simulates a number of paths. We then launch multiple tasks in parallel across our cluster, each handling millions of these paths. Ray automatically distributes these tasks across available nodes and aggregates the results. The more paths we simulate and the more compute resources we use, the more accurate our pricing calculation becomes. Now let's see this new integration in action. I'm going to run our Monte Carlo simulation on a Ray cluster provisioned by YellowDog. First, I'll initialize the RAIDO cluster described previously. Notice I'm specifying my YellowDog credentials and the desired cluster configuration, a head node, and several worker pools across different regions and instance types. You can see here that the cluster is being built, with 1,000 worker nodes being added. If we take a look at the YellowDog portal, you'll see these being provisioned and configured almost immediately in the cloud. In under a minute, YellowDog has provisioned 1,000 cloud nodes, giving us 2,000 vCPUs. This is the power of YellowDog's provisioning engine at work. Through the SSH tunnel our integration has established, I can access the Ray dashboard. Here we can see our cluster is healthy with all nodes connected. Now I'm submitting our Monte Carlo simulation. We're going to run 100 million path simulations distributed across all our nodes. Ray is distributing these tasks across our cluster. Each node is processing its share of the samples independently and in parallel. And now we have our results. With 100 million samples distributed across our Ray cluster, we've estimated the mean option price to be $10.45051, accurate to 5 decimal places. The entire computation used 49.8 minutes of computation time, yet was completed in just 53 seconds on our distributed cluster. Without YellowDog and this integration, provisioning this infrastructure would have taken significant time and effort. By deploying this way, we went from code to results in minutes. YellowDog integration for Ray is open source and available on GitHub. Documentation and examples are available at the URL below. Thank you for watching this demonstration. When you're ready to try YellowDog for your own projects, visit yellowdog.ai to book a demo or get started with a trial.